Everyone ready to pay attention? Sure? Okay, entonces in the last class, I remember that we studied the polynomial and rational inequality. Entonces now inside this topic, we studied some special case in which you delete some factor or you partial delete some factor. Let me record the idea. For example, in this, you know que the factor que contain exponent even always are positive. And the positive doesn't affect the sign of the inequality. You know, basically the rule for find the sign of the inequality is use, for example, you have negative times negative is positive. You have negative times negative times negative is negative. So basically, so you have even number of negative positive, you have up of negative is negative. Now, the control of the sign of the inequality depending of the amount of negative and not the amount of positive. Therefore, if you see that the sign of the inequality is less than or greater than, it's partial delete. Partial delete. Well, see the sign is less than or equal or greater than or equal is totally delete. So in this case, it's partial. It's partial. Therefore, you in your mind, you understand that this inequality is equivalent to, say, x minus 5, only this is partial delete. And you put less than 0, and the partial means can you consider que x no 4. Because in 4 we have a whole. And you solve this elementary inequality, that is x less than 5, and x no 4. And this is, you consider like a compound inequality. To understand this compound inequality well, you are doing the number line, case infinity, negative infinity, 0 here, 1, 2, 3, 4, and 5. Okay, this piece is from 5, but on the left because it's less than. Of course, no include 5. Okay, let me use a yellow color. Yellow. Another click. Okay, this is parentheses. And this continue forever. However, that part is a whole. Whole where? Whole in 4. So in 4, we have a whole. Let me using again yellow color, a whole, like that. Therefore, if you write the final answer in interval notation is from negative infinity, comma 4, is this piece. Stop here, because in 4 we have a whole. This is 4. Union 4, comma 5. Something like that. Clear or confused? However,
it's clear.
Okay. I bring another example, more complicated. Okay, but we apply the same idea. Suppose solving this inequality. X plus 1, x minus 2 square, x plus 5 square, and x minus 3 square. No square, sorry, less than 0. Suppose this inequality. So you delete something or partial delete something. What do you think? Opinion. So this inequality is equivalent. You copy the factor que contain in general odd exponent, because this exponent is 1, no? Si es 3 or 5 is the same. You copy x plus 1, x minus 3, less than 0. So you reduce the size of the inequality, but you consider the restriction that x is not equal to, look for this guy, comma, x not equal -5 for this guy. Que is the value in which this factor is 0. Because 2 minus 2 is 0, and -5 plus 5 is 0. This is the idea. Okay? Okay, this is just a whole. I don't know if this whole lie inside the solution or outside the solution. So I want to understand this idea now. Okay, so we focus in this inequality. It's easier than the original. The original look like horrible. This is easy. And you determine two critical values. Critical value 1, critical value 2. Remember, critical value is when you consider it, that this sign is equal, like equation. Entonces es obvio que es -1 and +3. And using this critical value, I make the partition at the order number 9. Okay, look at that. This is 0 in the middle, -1, +3, 1, 2, 3. This is the partition. And you select arbitrary testing point. Arbitrary testing point. For example, I select -2 in each interval. I select 0 because it's nice. I select 4. Because we have two partitions, we have 3 intervals. You select arbitrary testing point inside each interval and you testing. Si pass the test or fail the test. Okay, the table to testing look like that. TP. TP R -2, 0, and 4. That's it. The column is the factor that we are testing. The factor that we are testing is x plus 1 and x minus 3, sorry. And one extra column in which you put the total sign. -2 plus 1 is negative. -2 and -5 is negative. And -3 is -5 is negative. This is positive. 0. 0 es positive. 0 es negative. Entonces es negative. 4 is positive. 4 plus 1 is 5. 4 minus 3 is 1, positive. Okay, the only guy that satisfies this equation is this. Because our inequality is less than. And less than es sinónimo, es equivalent to say negative. Okay, entonces my interval, I suppose que look like here, right? Because the only testing point that passed the test is 0. -2 fail. And +4 fail because it's positive. Now, the consideration of the whole. We have a whole N2. Look at that here. 1, 2, 2, a whole. Here we have a whole in -5. -5, suppose que is here. But the problem is that -5 is completely out the interval that we discovered get the solution. Therefore, the answer of this problem is an interval notation, parenthesis, -1, comma 2, parenthesis, of course, because a whole, union, 2, comma 3, parenthesis. Okay, so our solution contains 2 pieces. The first pieces is this, until 2, because in 2 I know that we have a whole. Unfortunately, no. I am happy for this. -5 is completely out the game. So I ignore. This example is very, very illustrative of the different options that we can find in the solution for it. polynomial, no? Inequality when you have a special case and you realize it's special because the exponent is even. When the exponent is even, you depending the sign, you delete or partial delete. In this case was partial delete. Do you understand this or no? Any question? Complicated? Hard? No?
Alex has a lot of these.
Say again?
I said, Alex, I worked on the homework already. It has a lot of these.
Uh-huh. David, when you have a question, let me know, right? The only thing you should do is take a picture or create the screenshot and send me the question that you want to help, okay? Or you go to the tutor service. Today is Friday. Friday I am working at 11 o'clock in the tutor service. Okay, let's continue doing, but now I want to change a little bit because this example now is using rational inequality. Okay, similar, same procedure. Rational inequality. And rational is the same idea you know about the rational function. No, it's a polynomial divided by another polynomial. No, so es x minus 2 divided by x minus 1 times x plus 1 greater than or equal to 0. Suppose that we solve this inequality. Okay. This example is super straightforward because everything is done. Because somebody know me, when they create that problem, factorization, this polynomial, and factorization, this polynomial. Nice. I appreciate so much your help. Okay, another problem I want to see after that. No, I give you completely disorganized rational inequality into say you manipulate algebra to put in this way. This way is polynomial at the top, polynomial at the bottom, factorization, and in only one compact rational function. Okay, so you have two rational functions, then you combine or you condensing in only one. Okay, but no. In this case, nice. In this case, easy. So now immediately I determine the critical value in the top. The critical value on the top is x minus 2 equals 0. It's obvious. It's obvious because x equals 0 and x equals 2. Likewise, critical value in the bottom is x minus 1, x plus 1 equal to 0. So says x equal 1 and x equal negative 1. Okay, and using these four critical values, we are doing the famous partition of the all real number line. Negative infinity, positive infinity. Okay, we have a 0 critical value. We have in 2, 1, 2 critical value. We have in 1 critical value. Wow, too many. And negative 1 critical value. Okay, so basically 4 critical value, 5 interval, 5. 1, 2, 3, 4, and 5 interval. Look. 1, 2, 3, 4, and 5 interval. And obviously 5 testing points I need to select. So I select negative 2 belong to this interval. Here I select negative 1/2. Negative 1/2. I select here positive 1/2. I select here 1.5, 3/2. Yeah, I select here 3. Totally arbitrary inside it. And you create the table. And you create the table. Let's do the table. Here, over there, table. The table is long because we have 5 testing point, -2, -1/2, +1/2, 3/2, and 3. The factor involved in my problem are I listing any factor. In this case, no even exponent. Can you delete or partial delete? No. This is the exponent odd number 1 in this case. Entonces x is x minus 2 is x minus 1. And x plus 1. And the last column is the total. Okay, I fill out the table. Well, this table is this column is super easy because it's the same sign. Negative, negative, positive, positive, positive. Because it's just plugging in x. No subtraction, no addition. And -2 is negative. Because -2 and -2 together is -4. No? And -2 and -1 is negative also. And -2 and +1 is negative. 4 negative is positive. 1/2 is negative. Negative is obvious. And positive. Because -1/2 plus 1 is +1/2. Entonces 3 sign is negative. We continue. This is super easy. It's just imagination, plugging in, and determine the signs is positive or negative. Okay, entonces 1/2 is positive, is negative, and positive. 2 negative is positive. And 3/2 is negative, it's obvious. It's positive. Okay, because 1.5. 1.5 minus 1 is 1/2. And this is positive. 1 negative and negative. And the last column is positive because 3 is too big number. And those are positive. And we come back to our original inequality. Look at that. I saw that part greater than or equal 0. This is synonymous, equivalent to say positive. But the only testing point que pass the test is the testing point que in the total column have positive. This guy, and this guy. Okay, entonces I highlight, let me use another color. I don't like, maybe blue is much better. Okay, basically this interval belongs to the solution. So 2 is good. Look. This is good. And half, positive half, no? Yes, here, that interval. And 3 also, okay, this interval. Let me make it zoom to see more clear. And what about the endpoint? Be careful with this idea, the endpoint, because here, blue color. Because our inequality is no strict inequality because contain equal sign. Because actually, our inequality is inequality that part and equation that part. That means that some critical value belong to the solution. But what critical value? The critical value of the top or the critical value in the bottom? Never the critical value in the bottom belong because 0 in the denominator is undefined. You know that. And the only que belong is 0 and 2. Okay, entonces 0 is okay, bracket. Include 0. 2 is okay, bracket, and the rest no, okay. Parenthesis and parenthesis. So what is my final answer? My final answer is, my final answer is from negative infinity, comma, -1, que es this piece, this is this piece, union, the second piece, que es bracket, 0,1, paréntesis, que es this piece, union, bracket 2, infinity, que finally is this piece. Done. Any question? Guys, I repeat one more time. The method for solving this kind of inequality, rational polynomial, que actually is non-linear inequality, is not using algebra. Well, using one part of the algebra. And another part is using this method que is graphically and table, okay? And you evaluate. There are many ways, there are different ways to do that. I explain this way because I consider it's easy. But another teacher, another students, another school, another college, well, doing a little bit different. But it's okay. Get the same answer. This is very, very nice. I bring another more complicated example of the rational. We continue rational now. More complicated example in which we need to consider new situations. But it's no big deal. No big deal. It's easy. Okay, there you go. Suppose this. Pay attention. This is a little bit different. Suppose this. 1 over x minus 2 less than or equal 2 over 3x minus 9. The people that don't know the systematic way for solving this, I saw every day some people try to apply like a cross multiplication like that. Look, see this equation, yes, you can do that. Multiplication this and multiplication this. You can do that, si es equal. Pero si es inequality, no. Why no? Because you don't know. See this sign, you put it here or this sign. And remember, the inequalities are picky because when you multiply by positive number, stay the same, good. But when you multiply by negative number, it's reverse the sign. Exactly, we don't know what is the number. We don't know. See, we don't know, entonces what decision? I consider both decisions. Yeah, you can, but it's too long process. Okay, entonces now, always, you need to manipulate the inequality in order to the right-hand side, I move this guy to the left. The right-hand side must be 0. This is mandatory. Right-hand side must be 0. Why 0? Because 0 is the level of the comparison. Okay, above the 0 is positive, below the 0 is negative. In the table, I can see that. Okay, this is the true way. Another completely crazy. Okay, now it's completely different to the previous example because in the previous example, we have no two fractions. We have only one condensing and compact fraction. Well, okay, no problema. I know algebra to condensing this. So now you need to find the least common denominator, LCD. But before that, I factorization this expression because I see que 3 is a common factor. Because actually the LCD is everything together. It's 3, x minus 3 times x minus 2. Remember the rule for finding LCD, you take every factor except when you have repetition, you take the majority. But in this case, no repetition. The factor is different. X minus 2 is one completely different factor to x minus 3, and it's completely different factor to 3, it's just a number. Okay, so now you're condensing this fraction is only one, is 3 LCD, x minus 3, x minus 2. This is our new denominator. What about the top part? The top part is easy. You divide mentally LCD one by the each denominator one by one and multiply by the corresponding numerator. So basically you divide this divided by this. It's obvious that x minus 2 is cancelled mentally in my mind. Stay alive. 3x minus 3 times 1 is 3x minus 3. Minus, this is this minus 2 times is this 2. When you divide this divided by this, it's obvious that this part cancel out. Stay alive, only x minus 2 is x minus 2. Do you understand this algebra? Do you understand this algebra? We finished, no? Or no? Of course, now distributed. We have 3x minus 9 minus 2x plus 4 divided by 3x minus 3 x minus 2. You combine later. I can see clear. This and this is like 3 minus 2 is 1 x and negative 9 and positive 4 and negative 5 divided by 3 x minus 3 x minus 2. Less than or equal to 0. Bang. And this is my inequality. Okay, by the way, is equivalent 100% with the original. Okay, nobody understand very well. Nobody understand this. This is crazy. And some people try to make cross multiplication gets impossible. Now we focus in this. We focus on this. We solve it exactly the same we are doing before. We are doing before the previous example, no? When you have one case given easy, one compact expression. Okay, no problem. To say focusing, forget about the rest. Now this is my problem now. It's equivalent to the original, yes. Okay, one more sophisticated detail. Okay, you know, in the table, the important information is the positive, is the negative, sorry. The positive is totally irrelevant. You ignore this. 2 negative is positive. 3 negative is negative. And so you analyze only the negative. The positive is totally irrelevant. That is the reason that we delete the binomial to contain even exponent because it's positive. Always positive, always positive. You delete. So what's the reason to have in our inequality that 3? We can delete or no? Let me know. Is possible delete totally or no? Absolutely, because 3 is positive. So okay. In the test, maybe you see, well, no, okay, I get this answer. Suppose that you are doing one column. Okay, the column is, normally the column contains variable, x minus 3, something. The column 3. The column 3 is always positive. So it's completely useless. No, not necessary to do that. So this 3, the thing I try to explain is, okay, this 3 is completely irrelevant. And you can delete. Well, professor, is it negative? 3. Well, yeah. If it's negative, well, let's see another example I bring now. If it's negative, then, well, you change the sign. You change the sign. You delete or you change the sign. Reverse. Because of negative. Okay, entonces sí, super easy my problem now. You find the critical value. The critical value on the top is 5. The critical value in the bottom is 3 and 2. With this information, I go to the graphic part. Infinity, negative, infinity. I suppose que 0 is here. 1, 2, 3, 2, 3, 4, 5. Okay, partition in 2, partition in 3, partition in 5. I select completely arbitrary testing point. Maybe 1 is good. Maybe here 2.5 is good. Maybe 4 is good. Or maybe 6 is good. Okay, this is the good candidate to represent each interval. I create the table now. Testing point. We have 4. 1, 2.5, 4, and 6. The factor in our problem are, look at that, x minus 5, x minus 3, or x minus 2, doesn't matter the order. The order is not important. X minus 3 and the famous column total, in which you summarize the information. Okay, this is negative, so with 1 minus 5 negative. This is negative also. This is negative, 3 negative, and negative. 2.5 is negative. 2.5 here is positive and negative. 2 negative, positive. 4 is negative. 4 is positive, because 4 minus 2 is 2 positive, and 4 minus 3 is positive, is negative. And 6 is positive. No circle. I circle only the last in the column. Plus, plus, plus. Okay, I come back to my inequality. I see that my inequality is less than, or you can see, look at this is equivalent to say to be negative. This is the true guys is this. This and that. I highlight, okay, 1, okay, to say this interval, the solution. I extend it from negative infinity to 2 and 2 stop, because I know that in between 2 and 3 we have another interval. Okay, by the way, 2.5 failed. So now past F4, another interval of 4, and that's it. What about the testing point, the endpoint? The endpoint belong, yes, but belong only the critical value in the top, because this is equal. This is equal. So you plug in 5, for example. 5 minus 5 is 0, and 0 is equal to 0. So 5 is okay. However, 3 and 2, no. 3 and 2 is a 0 of the denominator, can always simplify. Therefore, my final answer is from negative infinity, comma 2, parenthesis, union, parenthesis 3, comma 5. Bracket. Finals. Okay, so this example was fantastic because bring me new ideas. Idea number 1. You need to manipulate. So normally the example you can see in the test on paper is not ready to apply the method. You need to manipulate some algebra. You need to bring everything to the left. You need to guarantee the right-hand side must be 0. You condensing using algebra the left-hand side in one compact rational function. You determine the 0 of the top and bottom. You are doing the partition, and the rest you know. Evaluate testing point, determine the sign, some testing point pass, some testing point fail. Okay. Okay, I bring another short example to illustrate essentially the same idea. Look, okay, no super long, Si no es apply shortcut. For example, this. Suppose I give you this 3 over x minus 2 greater than 0. Solve that. Okay. 3 is a positive number. Okay. Entonces I cannot consider. Okay, go ahead. You say something, somebody, my internet? What happened with the internet? All right, let me see in the chat. This is, you have problem with the internet? Okay. My internet is out this morning, Professor Gabriel. Okay. Okay, Gabriel. Sorry. This is advantage and disadvantage of the online class. Okay, you need to have good internet. The thing I try to explain is, in this expression I see 3 is positive. And positive, I don't care. So this is equivalent to say x minus 2. This is positive divided by positive is positive. Remember, this is greater than 0. This is equivalent to say to be positive. No? And to be positive is equivalent to say greater than 0. Because 3 is positive, you know. Entonces, the only restriction is que the denominator expression is positive. So you convert this problem to look like complicated in one super elementary straightforward example. Okay? Entonces, this is equivalent to say this is 0, 1, 2. This is to the right. All right. Incluye 2? No incluye parentheses. So the answer is 2, infinity. Well, was easy, right? Suppose I complicate your life. I put -5 divided by x plus 1. Less than 0. Bueno, this is negative. To be negative, because this is equivalent to say negative, no? Less than 0 is negative. So this guy would be positive. So this is equivalent to say que x plus 1 is positive. Do you understand the analysis? Numerero es a constant number, pero es negative. To be negative, the total fraction is less than 0, que es sinónimo, ¿no? To say que es negative. The top part, the bottom part, sorry, must be positive. It's exactly the thing I write here. So this is x greater than -1. The solution then is infinity, negative infinity. This is 0, -1 here, greater than is in that direction. And of course, do not include -1. And the solution in interval notation is -1, infinity. Boom. Boom. Okay. This is good. This is a special case, no? Okay. I suppose it's enough. In the review package, we continue doing some problem of this, special case, no special case. Okay, let's move on to the last topic in the chapter 3. Let's move on to the last topic. It's super easy. And you remember in the intermediate algebra, I want to record something intermediate algebra, and in a few minutes I go to the college algebra. Okay, this is about the linear system of equations. So in intermediate algebra, frequently we are doing the problem, linear system of equation. Equation 1, 2x plus 3y equal 12. Equation 2, and this is my system. The system consists of 2 equations and 2 unknown, que es x and y. This is the problem we are doing in intermediate algebra. this is a problem que es en 2D, two dimension. Therefore, it's easy to understand that, for example, each line represents a line, and the intersection for the line is a solution. Maybe exist, maybe do not exist. If the lines are parallel, do not exist. And see the line is coincident, is infinity, many solution. No? But traditionally, the best way for solving this system is using elimination method. An elimination method, the key idea for the elimination method is you try somehow to get, for example, one variable you select. One, for example, negative 12y and positive 12y. So you create something artificially, you know, okay, if you multiply one equation by number, the equation stays the same. It doesn't change. So suppose I create, this is the key idea, elimination method. When you create this, you add in the equation. This is cancel out as zero, elimination. How you create elimination method in this case? Well, okay, I take advantage. For the equation 1, equation 2, we have minus and plus. If you multiply this entire equation by 3, and if you multiply this entire equation by 4, let's do it. 3 times 3 is 9. 3 times 4 is minus 12. 3 times 1 is 3. And this is identical to the equation 1. New, pero este es idéntico, este es equivalent equation. And likewise, you multiply 4 times 2 is 8. 4 times 3 is 12. And 4 times 12 is 48. And this is exactly equivalent to my equation 2. If you now adding equation 1 plus equation 2 by column mean the column of the x, the column of the y, que by the way is cancelled out, maybe intentionally. So you have 17 equal 51. Divide by 17 both sides. The answer is x equal 3. And this is the value associated with the x, but we need the point. It's a point. It's the order pair, x comma y. To find the y value, well, you select either equation. For example, in my paper, I select the equation number 1 because I consider it as good. And you plug in 3 here. So 3 times 3 minus 4y equal 1. 3 times 3 is 9. Minus 4y is equal 1 minus 9 is negative 8 divided by negative 4 y2. Okay, so the solution, the famous point with this line intersecting is the point 3, 2. I suppose you remember very well this is the intermediate algebra, the problem in 2 dimensions. The new thing in colored algebra is that you are doing now the system of equations, but in 3 dimensions. In 3 dimensions. 3 dimensions is 3 equations and 3 unknown. But don't be scared. It's easy. A little bit long, I know, but it's easy. Entonces, en 3 dimensions, each equation contains 3 unknown. Okay, for example. Let me put elementary example. No super big deal example. Look. X minus 3y plus 3z. We have x, y, and z, 3 dimensions. Equal negative 4. This is my equation number 1. I put a number here, identification. Equation 1, equation 2, equation 3. Basically, the problem that we are solving now is solution of the 3 equations with 3 unknown. 15. Equation 2. And 4x minus 3y minus c equal 90. Equation 3. This is the system. You consider like a one mathematical object. 3 equation, 3 unknown. And the representation in 3D of this is more complicated because in 3D is each equation is no line. It's plain like that. Look, let me show you. I have a picture here, I suppose. Oh, I already no here over there. Look, the representation of the equation in 3D in 3-dimensional space. Remember, in 3-dimensional space, they have using your imagination, 3 dimensions. You have 3 axes: the x-axis, the y-axis, the z-axis. And this represents using the imagination guide. This is the corner of the. This is the floor, and this is 2 walk. Okay, or the ceiling and 2 walk. Okay, so now the representation of the equation in 3D is a plane. It's a plane. No line, plane, 2 dimension. So the relationship is complicated now because we have 3 equations, we have 3 planes. I need to discover intersection. So we have no 3 possibilities, we have a lot of possibilities. For example, in this, we have no solution. Why? Because this plane is parallel and never meet and never have solution. Okay? Entonces it's impossible to have solution. There are no intersection. No intersection. In this case, yes. It's intersecting, but no in the point, using the line. So we have infinity, many solutions. In this case, no solution also, because wow, between the yellow and the red plane, we have solution, but between the yellow and the green, we have solution, but we have no solution in between the red and the green. And we need to find a common something in between red, yellow, and green. No. Here, no solution also. And here, yes. And this is the case that we are studying, of course. Suppose the yellow plane, the green plane, and the red plane intersecting in this point. And this point is the solution that I need to find. Okay, by the way, it's the triplet order x, comma y, comma z. I need to find the component, something, comma something, comma something. Okay, in this example, maybe it's 5, comma 1, comma negative 2. Okay, do you understand the idea in 3D? It's, don't be scared because I never see you do the graph of this. So the thing is solution. Solution of this system. I want to explain it now. Pay attention. What is the procedure? What is the methodology to solving this system? Well, okay. You pair 2 equations. So now, you apply elimination. So I rewrite again the equation 1 because I like. I put a label to the identification. It's equation 1. And the equation 2, I copy together. Okay, super. And I select arbitrary. No. I select because I saw que negative 3y and positive 3y is ready for elimination. So when you adding equation 1 plus equation 2, this is 3x. So 1 plus 2 is 3. This is cancelled out. Okay, and 3 minus 1 is 2. And the right hand side is 11 because 15 minus 4 is 11. Okay. Entonces now what's going on? Well, I get a new equation I want to call equation 4. But equation 4 is nice because contain only two unknown, X and C. Y disappear in the process of the elimination in the first one. And for a moment, it's okay. Now I need to pairs two new equations, 1 and 3 maybe, or 2 and 3. But the most important thing is that if you elimination Y in the first couple 1, 2, you in the selection, for example, 2, 3, they want to copy. They copy 2 again. Guys, it's extremely important, the organization and the complicated problem. So is you need to keep an organization of this. I copy the equation 3. Look. Entonces now the important thing is, listen to me, this is the most important thing I want to say today. See you elimination Y here, elimination Y, you have to elimination the same verb. In this case it was easy, but not always this is elementary, elimination Y and the second couple. Okay, when you add in 2 plus 3 equation, it's obvious that we have 6x in the column of the x, the y disappear, exactly the same happen here. And so you eliminate y here, and you eliminate x here, or z here, you are in big trouble. No good. Minus 2c, because negative 1 together is equal 34. 34. It's equation 5, I call it. So in this moment, wow, almost I finish because we have two equations. I copy that. And two unknown. I copy 5 here together with the form a system, but this system now is similar to the system that we are solving in 1033 intermediate algebra because we have only two unknown. Okay? So in this case, easy, I can say, wow, fantastic for elimination C. So you add in the equation 4 plus equation 5. We have 9. 3 and 6 is 9. This is cancel out. Nice. Not always happen. I select this example, okay, everything flow easy. But in the real life, no, not too easy. Entonces, S equal, and you add in here 45. 45 because it's 5, 45, yeah. But by 9, x equals 5. At least I have in my hand one component of the famous point solution. To find the rest, well, do we come back to the original equation? No. Why no? Because the original equation contains 3 unknowns. I have only in my hand x. Therefore, I propose you go to the equation 4 or equation 5. In order to find, see, I have x in my hand, find z. In my paper, I select the equation 4 because I like. I don't know, there are no special reason. So plugging in 5 into the equation 4. So 3 times, replace x for 5 plus 2z equal 11. It's 15 plus 2z equal 11. 2z is equal 11 minus 15, que es negative 4, divided by 2, divided by 2, divided by 2, c is equal negative. Wow, amazing. I have in my hand 2 components. Now, you feel free to select the original either equation and plug it in. I select number 2. I have no idea why. But if you select another, the answer doesn't change. It's obvious, right? So in number 2, just 2x plus 3y minus c equal 15. I know que 2 es 5, el x es 5, sorry. why is exactly the last component I don't know. Be careful with the sign because it's minus c, is c is minus 2. Now this minus is this minus, subtraction. And this minus is the minus of the value for the c is negative. It's equal 15. Okay, this is 10, 3y, double minus is positive. 10 and 2 together is 12. 3y plus 12 equal 15. Therefore, 3y, let's continue here. 3y is equal 15 minus 12. Okay, obviously it's 3. Divided by 3 both sides. Y is 1. So what is my final answer? My final answer is in the three-dimensional space, the triplet order in this x, y, z. In our example was 5, 1, negative 2. Boom. End the story. Any questions? Super clear? Any question, guys? Let's do one more. Similar. Any question? This is, come on. You need practice, I suppose, no? You need practice. Come on, opinion. Villamizar, it's okay? You follow me? Kendrick? Yasmin, it's okay? Good, very good. Santana? Okay, super. Let's do one more. Now, well, so I propose you after that, start doing the review. I don't send the review package, but I want to send. Okay, I put in the whiteboard. So let's do one more to see some detail of this. Okay, one more example of the 3 equation and 3 unknown. Problem of the linear system of equation in 3 dimensions. 3 dimensions. Okay, look at that. 3x minus 2y plus c equal to, this is my number 1 equation. The second is 5x plus y minus 2c equal 1. Equation 2. The last, 4x minus 3y plus 3z equal 7. Equation 2. And this is my system that I need to solve. Okay? As always, you select 2 equations. I select the equation 1 and equation 2. Okay, what is the intention? Well, the intention, I have no idea, but I select. Let me see. I copy 3x minus 2y. Remember the organization, guys, important. I copy separately the equation 1. I copy separately the equation 2. I make a decision to elimination z. Why? Well, because here is positive 1 and here is negative 2. Because if you multiply the equation 1 by 2, by the factor 2, Maybe when you multiply by 2, this coefficient now is plus 2 and minus 2 is ready for elimination. But when you multiply the equation 1 by 2, we have 6x. This is the transformation from this to this. Minus 4y plus 2c equal 4. And this is my new equation 1. Okay, if you want, you forgot this. It's not important now. Okay, because when you add it now, equation 1 plus equation 2. Okay, es obvio que the z is cancelled out. Boom. So we have 11. I column, guys. Minus 3y equal 5. This is my equation 4. Super, super good. Let's continue. Okay, now I copy down. I copy here. Again, the equation 1, because I want to combine 1 and 3. Okay, why not? So I copy 3x minus 2y plus z equal to equation 1 I copy again. And equation 3 I copy, okay, 4x minus 3y plus 3c equals 7. It's equation 3. But the most important is that you need to eliminate the same variable. You eliminate z, elimination z in the first column. And you elimination c also in the second column. I propose you multiplication the equation number 1 by negative 3. The factor that we're using is time negative 3. So if you multiply by negative 3, it's negative 9, because negative 3 times positive 3 is negative 9. Negative 3 and negative 2 together is 6y. And negative 3 times z, negative 3z. And negative 3 times 2 is negative 6. And this is my new equation 1. So you forget this. I don't care now. If I apply elimination one more time. You adding by column. This is negative 5. This is positive 3y. This is elimination, the same elimination. Look, I eliminate z here, I eliminate z here. Equal 1. And this is my equation I want to call 5. And put together 4 and 5. Negative 5x plus 3y equal equation 5. Oh, nice. I like that. Because by coincidence, y is ready for elimination. Not always happen, guys. I select exactly good problem to make easy the explanation. Now, if you add in equation 4 plus equation 5, it's obvious that the y part disappear. And we have now 6. Because 11 minus 5 is 6 equal 6. Because 5 plus 1 is 6. Divided by 6, both sides. X is equal. Boom. Very, very good. If you want to find the next variable, well, I select the equation 4 or the equation 5. In my paper, I select equation 4. It's 11 times 1, because x is 1, I know that, minus 3y equal 5. 11 times 1 is 11. Okay, now solve for y. Linear equation, only one unknown, guess y is super easy. Minus 3y is equal 5 minus 11, okay, negative 6, divided by negative 3 both sides, y is 2. Now. In order to find the z, you go to the original equation that contains three variables, x, y, and z. In my paper, I select the equation number 1. Okay, number 1 is 3x, 3 times 1, because I know that x is 1, minus 2 times y, que I know que es 2, plus c, que I don't know, is equal to. Okay, so we have 3 minus 4 plus c equal to 3 minus 4 is negative 1. C is equal to plus 1. C is 3. And my famous solution point is the triple order 1, 2, 3. This is x, this is y, this is c. Boom. Okay, I propose doing another. A ver, a lot of time. No. Let's move on to the review. The review. Okay, the review I need to upload in the whiteboard. Okay, sorry, I forgot to do that. But it's okay. Let me try. Review. Guy, any question? Do you understand very well the procedure? Of course, you need practice, no? It's always happening in mathematics. Practice. Okay, then let me see here over there. Okay. Documents. I promise in the email I will send after with the video. I send the review. Let me see where is. Okay, there you go. It's this and this. Review for the test 3. There you go. Okay, open the option in this one. Select. Boom. Insert the page. This is the page. So the thing is, I promise in the video, in the email, sorry, I will send when the class is over with the video. I send this package. Okay. Do you see or no? Do you see well? Or maybe make it zoom in. It's okay.
If you could zoom in, that would be great. A little more, please.
Okay.
Thank you.
One more?
No, that's actually great.
Okay.
Oh, went the other way. Perfect.
Okay.
Perfect.
Okay, good. Okay, let's do the number 1 problem. Number 1 problem, say. Wow. Here. 4x squared plus 13 x minus 12 less than 0. This is a classical polynomial inequality. Fortunately, right hand side is 0. In this case, already 0. I appreciate so much your help. Entonces, basically, I factorization the trinomial in the left hand side. So in the left hand side, we have trinomial. And this trinomial is, special, no nice, in which you need to multiplication this guy and this guy, gets 48, 48. Doesn't matter, the sign is not important. You multiply 4, okay, the first number and the last number is 48. And the combination, I suppose, is 16 times 3. Because 16 times 3 is 48. And 16 minus 3 is 13. Okay, I understand that. 4x squared, you replace 16x minus 3x minus 12 less than 0. Okay, so I convert the trinomial polynomial. Here I apply factorization by grouping. The great common factor in the first couple is 4x. We have x plus 4. The great common factor in the second couple is negative 3. And we have x plus 4. And x plus 4 is the common factor again. And we have in the last factor x minus 3 less than 0. Wow, fantastic. I like this guy. I enclose in the box because it's important. This is equivalent to the original, but it's super nice now to understand the solution. Because immediately I find the critical value. Critical value is when you put the equation equal to 0, therefore x plus 4 is equal to 0, therefore x is negative 4. This is my first critical value. My second critical value is 4x minus 3 equal to 0. And when you solve this, 4x is equal to 3 divided by 4. X is equal to 3 over 4. Okay, if you want to see in decimal, it's 0.75. I put in decimal because I have some idea exactly the position que lie in the all real number line. This is my all real number line. Remember, guys, in the test, I want to see this part of the algebra. Now, in that moment, it's a graphic part. And finally, we are doing the table, no? So now partition. This is 0 in the middle. Partition is negative 4, negative 1, negative 2, negative 3, negative. Partition here. And 1, 2, 3, 4. And 0.75 is in between 0 and 1, close to 1. 3/4. Actually, we have 3 intervals. This, and that. Entonces, I have no idea what the interval solution. Therefore, I select testing point. One testing point here. Okay, select here, get negative 5, good. Another 0, I like some more. 0 because it's easy to evaluate. And another testing point, maybe 1, maybe 2. I select 2. 1 is possible. 3 is possible. Any guy in this interval have the same behavior design. Therefore, you select completely arbitrary. Some students select different like me, however, get the same answer. This is the beauty of this. Okay. Set up the table. The table is TP. The TP in our problem is negative 5. Is 0. And 2. 3. The factor involved in my problem is x plus 4 and 4x minus 3. Okay, and the final column important is the total. Okay, negative here is over the negative, because negative 5 plus 4. Negative here is a negative. Because 4 times negative 5 is negative 20. Minus 3, negative 23. To say it's positive. 0 is positive, so yeah. And 0 is negative, therefore negative. 2 is positive, and 2 is positive also because 2 times 4 is 8, 8 minus 3 is 5 positive, it's positive. I come back to my original inequality. I can see it's less than 0. Look at that, that part is important. And less than 0 means negative. The only true is this guy. Chung. Therefore, the only testing point that passed the test was 0. 0 is the good guy. Negative 5 and 2, no. And you select this interval. Okay, remember, 0 is totally arbitrary testing point in the middle of the interval solution. Therefore, you select the interval. You highlight the interval from the partition to another partition, no? It's the boundary defined. And the endpoint is obvious and not included inside the game because our inequality is a strict inequality, no equal sign. I don't see any equal sign. That means remember the critical value is the value of the zero. Therefore, no. That's when it's negative, it's the good guy. Negative is the good guy. Okay, this is what my final answer. My final answer then, parenthesis -4, comma, this number is 0.75, whatever you want to, or 3/4. You prefer in fraction or you prefer in decimal. It doesn't matter. Okay, super good. Any question? You feel strong in this solution? How do you feel? How do you feel? How do you feel? How do you feel? I don't know. I suppose that today we are doing everything too fast, no? I am doing okay, guys. I am doing okay. She said yes, okay. Because you are a good class. Okay, super. Okay, let's move on, continue.
We're a good class because we have a good professor.
No, both together. You are strong together.
It's a combination. If you have a great class and a horrible professor, everybody fails.
Okay, let me ask a question. You will enroll in the class for the next semester or no? Or not yet?
Next is I'm on calculus.
Okay, I teaching pre-calculus in the morning. Okay, the class after this, depending on your major, of course, is, so you need to take calculus. You need to take first pre-calculus and trigonometry. The Miami College offer separately that class or together. I teach it separately. I teach him. You can enroll in both if you want with me. Trigonometric is MAC. Wait.
This is for accounting majors or for math majors?
It's for the engineer.
No, I'm accounting.
Accounting.
Entonces, I was told that I had to take business calculus and I could take it next.
Yeah, you're right. Yeah. So, you need to take business calculus, and business calculus you don't need to take pre-calculus.
Right. I didn't see that, Professor. I didn't see your name on the list of calculus teachers.
Well, no. And this next semester I teach in trigonometric. I teach in integrate algebra, is called algebra plus pre-calculus and pre-calculus alone. Teaching 3 classes.
Oh, wow.
Yeah, it's no big deal for me. I teach 11 classes in one semester. When I teach in Broward College, I teach in Broward College and Miami-Dade College. So, no, it's not for me. No big deal for me. Teaching trigonometry. By the way, I saw in the roster que Victor Villamizar enrolled with me trigonometry. But the rest don't need to take that. In the business, I understand, David, you don't need to take this. Okay, trigonometry is MAC 1114. It's the name of the trigonometry. The pre-calculus is MAC 1140. Integrate algebra is MAC 1106, que es pre-calculus plus this class that you are taking with me now, 1105. Okay, this is 5 credit. This is 3 credit. And this is 3 also. Okay. So now I appreciate so much have good students like you. Okay. And we are strong together. Okay, number two. Number 2 is do the graph. Do the graph of that function. Okay, that function is a rational function. Number 2 question. F of x equal x over x plus 3. Okay, let's do it. We can open decimal or no. Estoy bajando. Okay, let me try to find the rectangular coordinate system. I have Where, carajo. No. Okay, try to find where's. Yeah. Picture. Ah, there you go. I found. Okay, this is the rectangular coordinate system. You. Okay, my goal is do the graph of this. Okay. And remember the 7 step. Okay, always we need to do. The first step is the factor 4. You know, the factor 4 is impossible in this example because at the top we have monomial and the bottom we have another binomial, but this is impossible to do anything. Okay, nice. I skip this step. The second step is find the y in the set. The y in the set is when the function is 0. It's the formula. Plugging in 0 divided by 0 plus 3. It's obvious it's 0. And when it's 0, it's 0, 0, no? Because remember, this is the x value you suppose, and this is the y value you suppose. I plot that way. And when this situation happens, normally it's because x and y, x in a set and y in a set is coincident. But just in case, let me verify that. The formula is f of x equal to 0, and we suppose that y is 0. Then you need to discover where the x is satisfied this. I copy that. Equal to 0 is equivalent to say x is 0. Bam. Again, we come back to the same one. No, frequently that happens. We don't happen. Okay, what is the next step? Okay, we are doing step 1, step 2, step 3, step 4 is the vertical asymptote. And remember, the vertical asymptote is you take the polynomial in the bottom, is x plus 3 equal to 0. Therefore, x is equal to minus 3. Okay, so we have vertical asymptote and negative 3. Yeah, I plot that. Look, vertical asymptote and negative 3. Vertical asymptote at x equal minus 3. Good. What about horizontal or slant? Is the next step. Well. What do you think? Is the degree analysis. Degree of the polynomial in the top is 1. Degree of the polynomial in the bottom is also 1. And I know by memory, same degree we have horizontal and no slant. At what value? At the leading coefficients, que is 1. Y equal 1. And thus I plot that. Horizontal asymptote. Horizontal asymptote at y equal 1. Horizontal line. Symmetry. I suppose que no. Que we have no symmetry. Pero bueno, okay, I try. Remember reflection? You replace x for negative x in our original expression. And when you try to manipulate, suppose I multiply top and bottom by negative 1 in order to put positive, and here you change the sign, it's 3 minus x. The thing I did was multiplication by negative 1, multiplication by negative 1, because I suppose that this helped me to understand much better. Pero I suppose que no. Well, when you compare this, and this is completely different. No even, nor odd is neither. That means to do that, we need to do the plot of the positive part and the negative part completely independent, no? Okay, entonces plugging in what value? Well, arbitrary. No, not totally crazy, no? For example, And the partition I can see in the x-axis, I have a point 0,0. I have negative 3 as the vertical asymptote. That would be fantastic, in my opinion. Select, for example, 1 point here, maybe 3. Maybe here negative 2. At least it's the minimum amount that we need. And here negative 4, negative 5. Negative 5 is okay. Then you evaluate in the original function that point, suppose 3. Is 3 over 3 plus 3. Oh, 3 plus 3 is 6. And reduce and lowest term is 1/2. Therefore, the famous point that we are looking for is 3,5. 3,5 is the half E here. The point, I suppose, is plotted here. So I understand a little bit. Well, okay, no, not too much. Let me continue with the negative. Suppose que I evaluate now in negative. Here's another point que select. Entonces, negative 2 divided by negative 2 plus 3. Okay, es negative 2 divided by 1 is negative 2. Therefore, the point is the point negative 2, negative 2. It's a coincidence. Negative 2, negative 2. Negative 2, negative 2 is here. Entonces, I understand at least that branch of the curve. Look, because I take advantage of the asymptote. Yeah, I know that the curve approaches pero never touch. Entonces, I did the first branch. Entonces, I need to understand the second branch, que I suppose que is in this direction. Let me select, well, I don't know. Let me select negative 5. I select negative 5, actually. F, evaluate, and negative 5. Entonces, negative 5 divided by negative 5 plus 3. And negative 5 divided by negative 2. Is 5 over 2. And 5 over 2 in decimal is 2.5. Nice. And the point is a point, negative 5, comma, 2.5. Post. Okay, I understand. And 2.5 is, look at that, negative 5, 1, 2, a half. I suppose that the point is here. If you want, you can select negative 4, negative 6, in order to understand much better. But no. I believe I understand. This is the behavior, and this is the behavior approach, but I'll never touch this. And this is our graph. End the story. Any question, guy? You think it's fantastic, this procedure? 7 steps, factor 4. In this case, no, not necessary factor 4. After that, Y-intercept, X-intercept, vertical asymptote, horizontal or land, depending on the degree analysis. One more information, symmetry, no symmetry. In this case, you see it's completely different. And finally, select arbitrary, not totally crazy, but arbitrary points, and evaluate the function. By hand or calculator, it's not important. Okay. Okay, let's doing one more example. Oh no. Stop here because I want to dedicate Monday to finish the review. Okay. Entonces, si hay, okay, this is enough for today. It's okay. Entonces now I promise que in few minutes, I will send the video. Let me stop recording.